Hi there, Joshua here, Factorising Quadratics. Let's see what we've got down here. We have a ruler, a calculator, of course, a pair of scissors, a candle, a red candle, and a bunch of keys. Right, now that I've cleared that stuff out of the way, let's start the lesson. Right, factorising quadratics. To understand this lesson, you need to be good at expanding double brackets. So this isn't something I'm going to teach in this lesson, but you need to be confident at expanding double brackets, just like this one. We could do this example now. We have x times x, x squared, x times minus 3, minus 3x, 4 times x is 4x, and 4 times minus 3 is minus 12. That can be simplified a bit. We've got x squared, and minus 3x plus 4x is 1x overall. So, alright, plus x, and then minus 12. So we end up with a quadratic expression, an expression with x squared. What we're going to be doing today is basically the reverse process. We're going to start with an expression like this, and we're going to rewrite it with double brackets. And that's what factorising is. It's just taking an expression and writing it with brackets. So we're going to be doing the opposite process. Right, let's do our first example. X squared plus 6x plus 8. So we have a 3-term quadratic here. It's got 3 terms, an x squared term, an x term, and a number term. And not all quadratics do factorise, but if they've got 3 terms and they do factorise, then they always factorise to a double bracket. So I'll just draw the double brackets. Now, what do we need inside the double brackets so that when we expand them, we get this expression here? Well, to get x squared, we would need x and x. X times x is x squared. Everything's positive on this side, so it's going to be 2 positive numbers in the brackets. I'll put the signs in straight away. And here, we're looking for we need a pair of numbers with a product of 8. Because the numbers here would need to multiply to give us 8. So what could they be? Well, there are 2 possibilities. Could be 1 and 8, or could be 2 and 4. We also have 6x here, so we're looking for a pair that if we were to expand the brackets, we'd get 6x. So do you think it's going to be 1 and 8, or 2 and 4? Let's try 1 and 8. Let's see if that works. You probably know that that doesn't work, but we'll see what happens anyway. To get 6x, we would need to do this inside product and this outside product. That's how you get the x terms when you expand the brackets. So 1 times x is 1x, x times 8, 8x, 1x plus 8x, is that 6x? No, it's 9x. So it doesn't work with 1 and 8. Let's try it with 2 and 4. Let's see if that works. And you may have known from the start that it would be 2 and 4. That's quite an easy way to tell. Let's see if we get 6x with 2 and 4. So 2 times x is 2x. X times 4 is 4x. 2x plus 4x does give us 6x. So this is correct. X plus 2 times x plus 4 is the factorised answer. The reason 2 and 4 works, of course, is because 2 plus 4 is 6. So we needed a pair of numbers with a product of 8, but a total of 6. So it was 2 and 4. Let's try another one. Let's do x squared plus 7x plus 12. So it's a 3-term quadratic. So if it factorises, it will factorise to a double bracket. What do we need at the start of each bracket to get x squared? Well, x times x is x squared. Everything's positive here, so it's going to be 2 positive numbers in the brackets. can't be negative numbers. As soon as you have negative numbers in the brackets, if you were to expand the brackets, you would end up with negative terms. There are no negative terms here, so it's got to be two positive numbers. Right, looking for a pair of numbers now with a product of 12. The numbers here and here, when you multiply them, you would have to get 12. So what could they be? 1 and 12, 2 and 6, or 3 and 4 are the three possibilities. And we have 7x here. We saw from the example above that for this to work, if we want to get 7x when we expand the brackets, then two numbers have to have a total of 7. So which pair here has a total of 7? Yep, it's going to be 3 and 4. It's got to be that. Let's just check that works. 3 and 4. Let's see if we do get 7x when we expand the brackets. 3 times x is 3x. X times 4, 4x. 3x plus 4x is 7x. So it works. This is the correct answer. X plus 3 times x plus 4. Right, let's try an example with minus signs now, see if that changes anything. So x squared, let's do plus 3x minus 10. So it's going to be double brackets, because it's a three-term quadratic. We need x and x, because x times x is x squared. Here, we're looking for two numbers with a product of minus 10, a negative number. So for that to happen, the numbers in the brackets must have different signs. One of the numbers is going to be positive, one of the numbers is going to be negative. So if we have a negative number here, the two numbers in the brackets must have different signs because they need to have a negative product. So I'll just write different signs. Now if the signs are different, I kind of forget about the signs and I only put them in at the end. So I'm going to ignore the signs, just focusing on the 10. I'm going to find two numbers, pairs of numbers with a product of 10. I'll work out what the signs need to be at the end. So pairs of numbers with a product of 10, 1 and 10, or 2 and 5. Okay, we've got 3x there. So when we expand the brackets, we would need to get 3x. So what we need to do is, because the signs are different, we're actually looking for a pair with a difference of 3 this time, not a total of 3. So which pair has a difference of 3? Yep, it's 2 and 5. Now let's see how that works. Let's see how that works. So 2 and 5. Is it plus 2 and minus 5 though? Or is it minus 2 and plus 5? Now we've got to decide which one's which. Well, when we expand the brackets, we want to get 3x. At the moment we've got 2x here and 5x here. For these to add up to 3x, which one would need to be positive and which one would need to be negative? Well, to get a positive total, 3x, the bigger one would need to be positive and the smaller one would need to be negative. So we would need positive 5x and negative 2x. That would work. So it's got to be minus 2 and plus 5. Minus 2 times x is minus 2x, x times 5 is 5x, minus 2x plus 5x is 3x. So this is the correct answer. X minus 2 times x plus 5. If the signs were the other way round, you'd get 2x here and minus 5x here if you were to expand the brackets, and that adds up to minus 3x, so it doesn't quite work. Right, let's do one more example. Let's do x squared minus 4x minus 12. So double brackets, x and x. Right, we're looking for two numbers with a product of minus 12, a negative number again. So again the signs are going to be different. Just write that down. So whenever there's a negative number here, that means the signs in the brackets are going to be different. One's going to be positive, one's going to be negative. And if the signs are different, as I said, I kind of forget about the signs. I don't deal with them until the very end. So I'm just going to focus on 12. I'm going to list pairs of numbers with a product of 12. 1 and 12, 2 and 6, or 3 and 4. We want to find a pair so that if we expanded the brackets, we would get minus 4x. Because the signs are different, we're looking for a pair with a difference of 4. If the signs are different, it's always the difference you're interested in, not the total. So which pair has a difference of 4? Yep, it's going to be 2 and 6. So let's just put them in. Now, is it plus 2 and minus 6, or is it minus 2 and plus 6? Well, we want to get minus 4x when we expand the brackets. So at the moment we've got 2x here and 6x here. To get minus 4x, which one would need to be positive and which one would need to be negative? Well, we want the total to be negative overall, minus 4x. So this time the bigger one needs to be negative and the smaller one needs to be positive. So it needs to be positive 2 and negative 6. 2 times x is 2x, x times minus 6 is minus 6x, 2x minus 6x is minus 4x. So it works with the signs that way round. Again, if the signs were the other way round, you would get positive 4x, which wouldn't be quite right. So this is the correct answer, x plus 2 times x minus 6. Right, just going to do a couple more examples now with minus signs in them. This next example is going to be a bit different to the last two, as you'll see in a minute. X squared minus 7x plus 10. So double brackets as usual. X and x. The reason why this example is a bit different from the last two is because we've got a positive number here, 10. So this time we're looking for a pair of numbers in the brackets with a product of 10, a positive number. So the numbers in the brackets could both be positive, but they could also both be negative, because a negative times a negative is also positive. So because the two numbers have a positive product, they've got to have the same signs this time. They're either both positive or both negative. So they have the same signs this time. Now actually, if the signs are the same, you can work out what the signs are straight away. We've got minus 7x here. That actually tells us that both numbers can't be positive. Because if they were both positive, if you were to expand the brackets, you wouldn't be able to get minus 7x, you wouldn't get any negative terms. So if the two numbers have the same signs, the only way to get minus 7x is if they're both negative numbers. So since we know that, we can put the signs in straight away. So if the signs are the same, you can always work out what they are straight away just by looking at this term here. It's a negative term, so the two numbers must both be negative numbers. Right, now we can sort of ignore the signs since we've worked out what they are and just focus on 10. So let's list pairs of numbers with a product of 10. Could be 1 and 10, or could be 2 and 5. And now we've got minus 7x here. This time, because the signs are the same, we're actually looking for a pair with a total of 7, not a difference of 7. If the signs are the same, it's the total we're interested in. So which pair has a total of 7? Yep, it's 2 and 5. So let's see how that works. 2 and 5. Let's just check we do get minus 7x when we expand the brackets. Minus 2 times x is minus 2x. X times minus 5 is minus 5x. So minus 2x plus minus 5x is minus 7x. So this is correct. X minus 2 times x minus 5. Right, let's just do one more example to finish off. X squared minus 9x plus 20. So double brackets, x and x as usual. And this time we're looking for a pair of numbers in the brackets with a product of 20. Again, a positive number. That means that the numbers in the brackets must either both be positive or both be negative. So again, the two numbers in the brackets must have the same signs. And we've got minus 9x here. So they can't both be positive, because you wouldn't be able to get minus 9x when you expanded the brackets. They've got to both be negative. So we'll put the signs in straight away. So just to summarise, if you've got a positive number here, that means the signs are the same. in the brackets, either both positive or both negative, and you can always put the signs in straight away. Just look at this term here. Here again it's negative, which means the two numbers must both be negative numbers. Right, let's list pairs of numbers with a product of 20. It could be 1 and 20, or it could be 2 and 10, it could be 4 and 5. We've got minus 9x here, so we're looking for a pair this time with a total of 9. Remember, if the sign's the same, it's the total we're interested in, not the difference. So which pair has a total of 9? Yep, it's 4 and 5. So let's see how that works. 4 and 5. That should be correct. Let's just check we do get minus 9x when we expand the brackets. So minus 4 times x is minus 4x. X times minus 5 is minus 5x. Minus 4x plus minus 5x is minus 9x overall. So this is correct. X minus 4 times x minus 5. That's the end of the lesson. I'm going to do another lesson on factorising quadratics because today we only looked at expressions that started with just x squared. Next lesson we're going to be factorising quadratics that start with 2x squared or 3x squared, so where there's some number in front of x squared. Hopefully I'll see you then. Bye!